The FJelinekSeries seminar series. So let me introduce Professor Joachim Nivre from Uppsala University. I should say that Joachim has a long-standing interest in dependencies in general, but probably most of you know him from the mold parser and the successor tools for dependency parsing. And of course, he is the main person and the main force behind universal dependencies, which is what we are going to hear today. I should also say that Joachim is a great friend, and in fact we had contacts since a long time ago, and when he was interested in what we do in the Prague dependency tree bank. So without much others, because I'm sure everyone actually knows Joachim, I would like to ask him to give the lecture.
Thank you very much. Jan. Thanks for inviting me. I'm always happy to be here talking about dependency and other related matters. I think you may have exaggerated my role in the universal dependencies. After all, several people here in Prague has also been very influential in promoting this project, including yourself and Dan and others who are here. So today I'm going to talk about enhancing universal dependencies, and I'll explain in a minute what that refers to. But I'll start with a little more sort of general background. I'm assuming, given that, as I said, this institute has been very influential in universal dependencies, that most people have at least heard about universal dependencies. But I also understand that you may know it to different degrees, so it might be useful to give a little bit more background first. So universal dependencies is an initiative to try to create cross-linguistically consistent morphosyntactic annotation. And the reason for trying to do that is to facilitate, in particular, multilingual research, both in NLP, oriented more towards sort of practical language technology, but also to the extent that it's compatible with those goals, more generally in linguistics. So the vision, if you like, of universal dependencies is to allow meaningful linguistic analysis across languages so that it makes sense to compare annotated data in different languages, even languages that are structurally perhaps very different. Syntactic parsing has always been sort of an obvious application when you're developing tree banks or morphosyntactically annotated corpora. And syntactic parsing in general should be supported by universal dependencies, but in particular in cross-lingual settings, when in one respect or the other, it involves using more than one language, where it is again important that sort of it makes sense to compare analysis across languages. More generally, sort of just as a practical tool for building NLP systems for multiple languages, where it at least makes things simpler and easier if you can sort of use the same system for multiple languages. And also, and this was, if you like, a positive side effect, something that at least I didn't think of initially, it turns out that having something like universal dependencies appears also to facilitate resource building for new languages. When you want to start building a tree bank or annotating data for a new language, having a standardized, in some sense standardized annotation scheme and lots of examples of tree banks in other languages makes it easier to sort of get started. Now, an important point to make is that, at least in my view, the goal of universal dependencies has always been to be a complement, not a replacement of language-specific schemes or frameworks. In order to sort of promote this goal of cross-linguistic consistency, you sometimes have to make compromises, and you have to make certain things a little more coarse-grained so that they can generalize across languages. And that means that inevitably, it's hard to capture all the finer details in a specific language. So when you're working on one language or a small set of languages, and you want to study or annotate every sort of little detail, UD may not be sort of the best tool for doing that. I think it's important to to point out that UD has never meant to be the annotation scheme to replace all other annotation schemes. Now, how do you actually achieve cross-linguistic consistency? There are many different ways in which you can do this, I think. UD is based on one particular perspective in doing this, where the idea is that you focus on grammatical relations like subject, object, and so on, or dependency relation if you prefer, between words. And words can be very morphologically rich in some languages and much less morphologically rich in other languages, but we can identify words across languages. And in particular, what we sort of usually refer to as content words. And I'm illustrating this with an example in English. The dog chased the cat from the room, and its translation into Finnish, apologies for my bad Finnish pronunciation, where you can see that structurally these languages are quite different. So in English, you rely on, it's not visible in the screen, but you do rely on word order to sort of figure out which grammatical relations, the fact that the dog is the subject and the cat is the object, is signaled by word order. And in addition, English makes use of grammatical function words like articles and prepositions. Whereas in this particular example, Finnish doesn't use any of these encoding devices, but instead it uses, in this case, nominal case morphology. So we have nominative, accusative, and elative to signal the grammatical relations. But at some level of abstraction, we can say that the English and the Finnish sentence has the same structure. There is a main predicate, which is a verb, and there is a subject, an object, and a locative modifier, or oblique, as UD would call it, right? And these little bubbles sort of are meant to signal the fact that in order to bring out this parallelism, we have to sort of align things that are single words in one language with a content word plus some grammatical markers, which are sometimes morphologically realized, sometimes syntactically realized. And some of them have no correspondence at all, so definiteness, for example, is not encoded at all in Finnish, as it is in many other languages. So this is sort of the basic idea. Now, the idea in universal dependencies is not really a project in the traditional sense with sort of funding and milestones and so on. It's more, I like to think of it more as an open community effort where anyone who is interested and is willing to contribute to this enterprise is more than welcome to do so. And it's been fascinating for the last couple of years to see how many people of different backgrounds, linguists, computer scientists, field linguists, and so on, and also people of sometimes very different theoretical persuasions, of which we can find many in linguistics, have found it worthwhile and apparently found something like UD useful enough to be willing to contribute their efforts. So in the latest release, we had resources for 60 languages, over 100 tree banks, and over 200 people contributing, for which we're, of course, immensely grateful. And even though, as I said, I know that many of you are already, in one sense or the other, involved in this, but we're always sort of welcoming more people. Now, the actual annotation, I'm not going to go into a lot of detail here because that's not the main point of this talk, but the annotation essentially consists of, there's a little more than this, but the main point is sort of three components. There is a set of part of speech tags, which is based on what used to be called the Google Universal Part of Speech tags. There is a system of morphological features that allow you to give a more fine-grained analysis of words, especially for morphologically rich languages. That is, again, sort of loosely based on Dan's and other people's work with the interset system. And then the syntactic analysis is in terms of syntactic relations or dependencies, which, again, originate from the so-called Stanford dependencies originally developed for English, but again have been revised and adapted in different ways to make them more suitable for cross-linguistically consistent annotation. Now, all I'm going to talk about today concerns the syntactic annotation. There are lots of interesting things to say about the morphological annotation, but I'm not going to talk about that today. So just very briefly, as I already said, the point of the syntactic annotation is to focus primarily on grammatical relations between content words. So again, if we have a sentence in English slightly longer this time, the cat could have chased all the dogs down the street. The idea is that we first identify the predicate, and then we identify its main arguments and modifiers. So cat is the subject, dogs is the object, and street is at least part of a locative modifier or oblique. Function words are then simply attached to the content word that they modify. So in a sense, they are treated as separate words, so they are sort of attached as nodes in the tree, but sort of at a more abstract level, they are more treated like sort of morphological features. If you want to include punctuation in the annotation, we have guidelines for that too. I'm not going to talk about that today, but that's also part of the guidelines. And again, the reason we focus on these relations between content words, which is not standard in at least all versions of dependency grammar, is that we want to bring out this parallelism again. Here I'm illustrating it with English, the dog was chased by the cat, and Swedish, my native language, Hunden jagades av katten. Two fairly closely related languages, both Germanic, but still different enough to illustrate this point. So again, if we take the relations between content words as the important ones, then these have a parallel structure with a passive, a subject, and an oblique agent phrase. The difference is that whereas definiteness is marked by a function word, an article in English, it's a morphological inflection in Swedish. Similarly, passive is a periphrastic construction in English, but it's a morphological inflection in Swedish. That's at least one of the possibilities. And when it comes to the agent phrase, both Swedish and English happen to use a preposition to indicate this relation, but I believe that Czech is a language where instead you would use the instrumental case. So, to illustrate that. Okay, so far so good. In order to classify syntactic relations, UNI makes use of a taxonomy of currently 37 relations. It has changed a little bit between versions of universal dependencies. And this taxonomy is organized by two main principles. The first being the expectation that in all languages we expect to find essentially three types of linguistic structures. We expect to find nominals or noun phrases who have, among other things, the function of referring to objects. We expect to find clauses that are built around a predicate together with its arguments and modifiers, where the predicate is often a verb, but where it can also be other types of words. And then we expect to find various types of modifier words, like adjectives and adverbs and so on, which can take dependence of their own, but which typically do not give rise to the rich kind of structures that we find in noun phrases and clauses. So that's the one sort of division. The second one is the distinction between core arguments, essentially subjects and objects, which seems to have a special encoding in most languages, and basically everything else, or at least on the clause level between what we refer to as obliques. And it's important to note that this is not exactly the same distinction as that between arguments and adjuncts, which has more with valency to do. This is more about the overt grammatical encoding. We do allow language-specific subtypes, so that the universal relations apply to all languages. That's the idea, but you can have specific subtypes that occur only in some languages. And this is going to be sort of the main point, essentially. We the syntactic annotation comes in two versions that we refer to as basic and enhanced, where the basic representation always forms a tree, and whereas the enhanced representation contains additional relations. So before we go into that, I just wanted to show you the complete taxonomy of relations. I will not have time to go through this in detail, but the organization of this table is such that in the first row, we have core dependents of predicates. And they can be either noun phrases or they can be clauses. And we have different relations for those. So we distinguish between nominal subjects and causal subjects, and objects and clausal complements. In the second row, there are other types of dependents of predicates, non-core. Again, they can be nominal, like vocatives and obliques. They can be clausal, like adverbial clauses. But they can also be modifier words like adverbs, or they can be a function word that is associated with a predicate to express, for example, tense aspect as auxiliaries and so on. In the third row, we have relations that occur inside noun phrases, and again, they are divided into the four structural types that we have. The bottom row are for, if you like, special phenomena. Coordination, of course, we need some way of annotating that. Certain restricted classes of multi-word expressions have special relations. There are loose joining relations like parataxis and list, and there are special relations for ellipsis, the orphan relation. I'm going to come back to that. Goes with is essentially for typographical errors in text, and referendum is for disfluences in speech. And then a few very general relations for things like punctuation. Dep is sort of the, if you really have no idea what something is, you can call it. Okay, so as I already said, the syntactic annotation comes in two versions. And the first is what we call basic dependency. And the properties of the basic syntactic representation is that it always forms a spanning tree over the words of the sentence. And that implies a couple of things. First of all, it implies that there is a one-to-one mapping from words to nodes. So once we have segmented a sentence into its words, every word will be sort of part of the tree, and nothing else will be a node in the tree. So there are no empty nodes or anything like that in the basic dependency. Secondly, the tree constraint. Every word has exactly, or at most, one incoming dependency, right? Or has one head. In this representation, the predicate verb doesn't have any incoming, but we can, of course, add an extra root node to make it the case that every word has exactly one dependency. Now, in general, this gives a representation of the syntactic predicate-argument structure that is sometimes underspecified in certain respects. So, in the case of coordination, where UD adopts an analysis where the first conjunct is treated as, if you like, the head of the coordination, and then we have a direct relation to the other conjunct, in keeping with this principle of giving priority to relations between content words. So in this representation, Sue tried to buy and sell stock. You can see in the representation it's explicitly represented that stock is a direct object of buy. But it's not explicitly represented that stock is also a direct object of sell. We can maybe infer that from the representation. I will come back to that, but it's not explicit. Similarly, we explicitly say that Sue is the subject of try, but we don't say that Sue is the subject of buy and of sell, even though we know that that follows from this grammatical structure because try is a control verb, right? Subject control verb. So, by and large, we can say that basic dependencies, because they are trees, are at least somewhat suitable for parsing. Some people have opinions that these are not the most suitable trees for parsing, but parsers in general like trees because they're computationally tractable and so on. But it's not always useful for downstream applications that, let's say, want to make a semantic interpretation of this structure, because some pieces of information are missing, some pieces of information that can be crucial for interpreting the sentence. And this is one of the problems, or maybe the problem, that enhanced dependencies is sort of designed to solve. So the idea in enhanced dependencies is that, first of all, it's not a tree in the general case. There are special cases where the enhanced representation is also a tree, but in general, it's a general graph structure. And it's not spanning anymore. So the mapping from words to nodes is more fluid, let's say. In theory, at least, there can be words in the sentence that are not nodes of the enhanced representation, although I don't think we actually have such cases yet. But we could. But we do have cases, and I will show in a minute, where we have nodes that don't correspond to a word of the sentence in some cases of ellipses. So in the general case, the enhanced dependencies is also not just a monotonic extension of the basic dependencies. This used to be the case in early versions of UD, but it's no longer the case that you just take the basic tree and then you add some more relations. In some cases, you actually change relations as well. And the idea is, or one idea is that it should disambiguate aspects of predicate-argument structure. So in the enhanced representation of Sue tried to buy and sell a stock, there is an object relation from buy to stock, but there's also an object relation from sell to stock. So that is now me. Similarly, there are explicit subject relations from buy and sell to Sue. Now, there are also some other cases, as we will see in the enhanced dependencies, where we're not really adding any information, we're just making the information more conveniently available for NLP applications, in particular by collapsing paths into single arcs for practical convenience. So I'll come back. So in the current version of UD, which is version 2, you refer to the guidelines, there are 5 types of enhancements that are described in the guidelines, and that they are somewhat optional so that you can decide which ones you want to implement, but these are the ones that are sort of, in some sense, part of the current standard. So null nodes for aligned predicates, shared heads and dependency coordination, of which we already saw an example, added subject relations in control and raising, which was also exemplified in the previous examples, co-reference in relative clause construction, and augmented modifier relations. So let's have a look at each one of them in part. So ellipsis, as I'm sure many of you know, is a tricky phenomenon both in theoretical linguistics and in practical NLP, because things are missing, things that you need to interpret a structure. In general, if we start with the basic dependencies, in UD, we treat ellipses in following these rules. So, first of all, if the aligned element has no overt dependence, we do nothing. If something just quietly disappears without leaving any sort of parentless children behind, we don't do anything. If the aligned element has some overt dependence, we need to do something with these, and the general mechanism is what we refer to as promotion. So we promote one of these to take the role of the head. Now, in the special case where the aligned element is a predicate, which is a particularly nasty case of ellipsis for any dependency analysis, and the promoted element is something like a core argument or modifier, we use a special orphan relation to attach. So I'm going to exemplify this and explain why we do it. So if we start from an example like she bought 2 apples and he bought 3 apples, right? And then suppose we omit the second occurrence of apples. So we just say she bought 2 apples and he bought 3. Now that's the second case that I had on the previous slides, where the head, apples, is elided and the numeral dependent 3 is left behind. And in this case, we promote the numeral 3 to be the head of the noun phrase, right? And so we simply use the expected dependency relation. 3 is now treated as the direct object of bought, even though it's in some sense short for 3 apples. So nothing special here. And in most cases that works fine. In other cases where the head noun is elided, there may be an adjective there that can take the place of the noun and so on. But suppose now we go one step further and we also elide the predicate here. So we now just say, she bought 2 apples and he 3. Now if we just apply the simple promotion principle here, we can promote the subject he to the head. And then we use the same relation as before, but now it's starting to be a little bit awkward here, because not only have we promoted 3 to be an object, we also get a representation where it looks like 3 is the object of he, which doesn't make grammatical sense, because he is the subject. And so this is the point where we draw the line and say, no, we don't want to do this, because people who are going to interpret these structures will draw the wrong conclusions here. So here in the basic dependencies, essentially all we do is put a little warning flag. Say, look, we've connected these pieces together so that we get a connected clause that is being coordinated with another. But this clause is incomplete, and the things that are attached to them don't have sort of a real grammatical relation between them, so we just flag that if you're doing relation extraction, don't fool yourself into thinking that 3 can be an object of he. This is just an artifact of the representation. Now, in the enhanced dependencies, the idea is that we're going to resolve this and actually get a correct interpretation of the predicate-argument structure. So in the enhanced dependencies, what we do, we insert an empty node here. I represent it just as empty here, but in most cases we just sort of make a copy of the verb from the other. And then once we have this sort of placeholder for a verb here, of course we can assign the correct relation to both he and 3. But note that we still just treat 3 as the object. We don't insert an empty node for the apples here, right? It's just in this special case of, this is a case of what is in the literature is usually referred to as gapping. Right? Now, sometimes we need more than one empty node, because in gapping you can sometimes make the whole verb cluster. So if you have, she wanted to buy 2 apples and he 3, the interpretation of that should be not that he bought 3 apples, but that he wanted to buy 3 apples. So we actually need both sort of an empty finite and an empty non-finite. All right. Second enhancement is about coordination. And as I said before, the dependency structure that we have for coordination in the basic dependencies is such that we leave unspecified many things. So the shared head is attached only to the first conjunct. So if we have, she likes alpine skiing and swimming, the head of skiing is likes, and that gets an object dependency, but the fact that she also likes swimming is not explicitly represented. Now, in the case of the shared head, this is completely unambiguous. I mean, we can sort of directly infer here that if she likes skiing and skiing is coordinated with swimming, then she also likes swimming. But when it comes to potentially shared dependents, it's more tricky. And especially for this case where it's being attached to the left of the first conjunct. So if we have a sentence like she likes alpine skiing and swimming, the structure and the representation doesn't tell us whether alpine modifies only skiing or also swimming. Now, using world knowledge, we know that there isn't a sport like alpine swimming, at least I've never heard of it. But in the general case, this kind of structure is always ambiguous. And the idea is that the enhanced dependencies should now disambiguate this, so it should add the missing link to for the shared head, and in this particular case, it should not add a link for the shared modifier. But in case the modifier really is shared, it should be added. That's the idea. And of course, if we have multiple cases of coordination, these tend to sort of multiply. So if you have a coordinated object, coordinated verb, and a coordinated object, sorry, did I say such? Yeah. Sue and Kim bought and sold stocks and bonds, and we get 4 subject relations and 4 object relations, and they should all be specified. Now, the one of the relations that we use in the basic dependencies is the excomp relation for open clausal complements, which includes, among other things, infinitives. So things like raising verbs and control verbs. These examples are both control. She tried to sing that subject control. She persuaded him to sing that's object control. But the idea is that whenever there is an excomp, it means that the phrase that is the excomp has its subject specified somewhere else. The subject has to be co-referential, if you like, with some argument or sometimes oblique in the higher clause. And again, the enhanced dependencies should disambiguate this. And the excomp is not only used for infinitives, it's also used for cases of nonverbal predications, so things like she considers her intelligent. Intelligent would also be treated as, or she considers her a fool, or something like that. They will all be excomps. Relative clauses. In the basic dependencies, relative clause, there is a relation from the antecedent noun to the predicate of the relative clause, and then the relative pronoun, if there is one, then gets a relation corresponding to the role that it fills in relation to that predicate. In the enhanced dependencies, there 2 things happen. First of all, a co-reference link is added from the antecedent to the relative pronoun, and then again this implicit subject relation or object relation, as it might be if it's an object relative, is also added. And finally, the 5th type of enhancement is what I call augmented labels. So when you have something like he went to the dinner after leaving work, the relations oblique and adverbial clause are very coarse-grained. But in many languages, you can get more information by looking either at the subordinating conjunction or similar in the clause, or at the preposition or similar in this oblique. And the enhanced dependencies just makes that information more easily available to stupid NLP systems that prefer to have everything represented as a single link, so that we get, so oblique to is a different relations from oblique in or oblique by, for example, and similarly for adverbial clauses. But as I said at the beginning, this is just a sort of a practical convenience. It does, unlike most of the other cases that I've shown, it doesn't actually add any information that wasn't in the basic dependencies. Okay, so far so good. It seems that enhanced UD representations can be useful for at least certain types of NLP applications. Now, one problem is that so far there aren't very many UD tree banks that actually provide enhanced dependencies. So we have to be sort of humble here and say that out of the 102 tree banks that I bragged about at the beginning, only 5 actually in the latest release has these enhanced dependencies. 2 of them are for the same language, Finnish, so there are only 4 languages that have them. And to be even more humble, we have to say that in most of these, possibly all, only implement part of the current guidelines. So the question is, what can we do to improve this situation? And what I'm going to do, sort of in the time remaining, is to talk about a case study that I performed recently together with people at Stanford, Sebastian, in Turku in Finland, Philip in Vienna, and in Pisa in Italy, at how we can bootstrap enhanced dependencies if we already have a UD tree bank with basic dependencies, plus some other tools. So essentially what we did here was we took 2 more or less pre-existing systems that we might refer to as enhancers, in the sense that they can take UD basic trees and output enhanced dependency graphs. So what I'm going to refer to as the Stanford system is a rule-based system that was developed for English, essentially to take English basic dependencies and try to produce enhanced dependencies. And the Turku system is then a similar system for Finnish, but it's a data-driven system based on machine learning because, as you may remember, Finnish was one of the few languages that already has some enhanced dependencies already annotated. Well, actually, English is also that, but that was actually produced using this rule-based. So it wouldn't make much sense to use that as training data. 2 target languages, very completely opportunistic reasons. We chose Swedish and Italians because both I and my Italian colleagues were interested in trying to develop enhanced tree banks for these languages. And we focused on 3 of the 5 types of enhancement that I talked about. So the added subject relations, the so-called propagation of dependencies in coordination, and the null nodes for elided predicates. We didn't focus on the last one, the augmented labels, because that's completely deterministic, so we know we can do that. And the relative clause depends on if you're also going to handle so-called, what are they called, headless relatives, where the relative pronoun, where there is no avert relative pronoun, it's definitely not deterministic. But if you only take care of the cases where the avert pronouns, it is deterministic as well. So, as I mentioned, the Stanford system is a rule-based system. It actually is an evolution of the original converter for the Stanford dependencies that produced what used to be called collapsed and CC processed Stanford dependencies, for those who have ever used something like that. It's mainly a rule-based system. It uses pattern matching to detect the structures to enhance, and the pattern matching there is very simple. You just know that if there is an XComp label, there should be a subject relation added. If there is a conj label, some arcs should be added. And if there is an orphan label, it means that there is some kind of ellipsis that needs to be added. It then uses heuristics to predict the enhanced dependencies, and I will look at those in a minute. And in the special case of ellipses, there is a new method that Sebastian and others are going to present at NACL this year, which is somewhat interesting. But let's start with the subject, the added subject in the XComp. So the heuristics that is used here is to say that from any node that is attached as an XComp to a higher predicate, such as this infinitive singular, add an n-sub dependency to either the object of this higher predicate, if such a dependent exists. So in this example, she persuaded him to sing. The upper predicate has an object, and therefore the algorithm will assign an n-sub here. If there is no object in the higher clause, then you just link it to the subject. So this is a very simple heuristics, but it turns out to be very powerful, at least in many languages. There are obvious and known counterexamples to this, like she promised him to sing, where promise is subject control, even though it takes an object. But such things appear to be quite rare. So this is what they do. For coordination, they go for a high precision solution. So they add the shared heads for all coordinated elements because, as I said, that's unambiguous. But in the case of shared dependence, they don't try to predict all types of shared dependence. They limit themselves to core arguments of conjoined predicates. So only if something is potentially shared shared dependent that is an object, a subject of some kind, or a clausal complement, do they even try to decide whether it should be added or not. Right, so in this case, they don't even consider this alpine as a possible candidate for propagating, which happens to be good for them in this case, because it would be wrong to propagate it. But of course, in many other cases, they will miss relations. When it comes to ellipses, or this special type of ellipses like gapping, as I already said, this is a new method by Sebastian, where the idea is that first of all, you try to align arguments and you have well, I'm not showing you the basic tree here, but in the basic tree you would have an orphan relation that would signal that you have some parentless things. You try to match those to arguments and modifiers in the complete clause, essentially using similarity of word embedding. So you look at word embeddings for these words, and you try to use similarity plus a very simple word order heuristics. So you assume that things should occur in the same order, and that way you can match, hopefully, she to he. They should be similar, have similar word embeddings. Matching apples to 3 might be a little trickier because of the added ellipsis here, but if it had been 3 apples, of course it would have been, or let's say oranges, and he oranges, then it would have worked. And this also, incidentally, tells you that whatever is left, or over here, then is the thing that you need to insert. So that's sort of the idea. And then you simply copy the labels from the things that you've paired it up with. So if this is paired with something that has an n-sub label here, you assume that this thing should have the n-sub label. Right. The Turku system, as I mentioned, is based on a data-driven system developed to predict enhanced dependencies for Finnish, trained on their tree bank with both basic and enhanced dependencies. It uses the same kind of simple pattern matching to detect the structures, and then uses a support vector machine classifier to basically, in a binary fashion, decide whether a candidate should be added or not. The original system had lots of Finnish-specific features. Now, most of those, of course, will not work in other languages. So this is a rather impoverished version of the original system that only has features that look at universal part-of-speech tags and a few morphological features that exist in many languages, like number and tense and so on. And this system does not handle the elided predicates at all, because that was not part of the standard at the time when they developed this. So in the case of added subjects, first of all, they only handle the special case of infinitive verbs, and they don't try to even consider object control. All they do is that for any XCOM that is attached to a higher predicate, they consider as a candidate dependency to add a subject dependency to the subject of the higher predicate. So they will consider this as a candidate here, and they will consider a link from sing to she as a candidate here, and then in a binary fashion decide using the SVM classifier whether that's a good dependency or not. So here they will hopefully decide to add this arc. Here the best thing they can do is to decide not to add an arc to n-sub, but they can never recover this one. That's the difference. When it comes to coordination, they take the opposite route to the Stanford system in going for high recall. So they add the shared head, just like the Stanford system does, but then they consider all dependents of the first conjunct as a potential shared dependent. And then uses an SVM classifier that either selects a label for that candidate dependency or predicts a special null label if it says, no, I don't think that dependency should be in there. Right? So it's interesting to compare these approaches because they are sort of, they use opposite strategies. Okay, so how do we evaluate this system? Well, neither Swedish nor Italian had annotations of enhanced dependencies, so we had to use manual evaluation. So what we did was we took 1,000 sentences from the training set for both languages and looked at all the subjects and dependencies in coordination that has been predicted. In the case of ellipses, which is a much rarer phenomenon, at least this special type of ellipsis. We actually looked at all the cases in the training sets, so to get more coverage. We actually have a slightly more fine-grained classification of errors, but I'm now, in this presentation, I'm just going to divide them into two types. What I call basic errors are errors where we find a predicted dependency in an enhanced representation that shouldn't be there, but when we actually look at the tree, we see, well, the reason is not because the enhancer has done anything wrong, it's because there was an error in the underlying basic annotation. This may come as a surprise to some of you, but tree banks actually do contain annotation errors. The enhanced errors are the ones where we believe the enhancers have made an incorrect prediction despite the basic dependencies being completely corrected. So that's what we're getting. Since we're only looking at things that these enhancers predicted and saying whether they're correct or not, we can really only evaluate precision. That we can say how often when the enhancer predicts something is the prediction correct. But since we have more than one system, we can do a sort of a kind of pooled recall, or relative recall as it's sometimes referred to in information retrieval, where we can say for a given system how many of the correct dependencies that the two systems together were found by that system. All right, so if we start by looking at, let's do that. If we start looking at the subjects, and we look at Swedish first, S is for Stanford, T is for Turku. For subjects, we can see that the Stanford system predicts many more subjects. So in 1,000 sentences, it predicted over 100, and the Finnish system only 36. Now, this is not an interesting difference. It's just because the Finnish system is limited to infinitives, whereas the Stanford system also handles all these cases of nonverbal predication, including simple things like the complement of become and so on. We see that the English system nevertheless has slightly higher precision. And this has to do, as I will show in the error analysis, with the fact that it does handle object control, which the other system doesn't. And of course, the relative recall, I mean, all we can see here is that the Finnish system only captures about 25% of the cases that the English system. We see that, especially for Swedish, slightly embarrassing for us, most of the errors were actually errors in the basic annotation. And there were, in fact, very few errors in the predicted dependencies. So it looks like we can do this with fairly high accuracy, good enough so that we can use it for bootstrapping, for instance. For Italian, the picture is similar, but yet a little bit different. So in terms of quantity, yes, the Stanford system again produces many more because it handles the whole range of phenomena. But interestingly, the precision is lower here. And actually, the Finnish system has higher precision. I will come back to that. Again, we find, at least for Swedish, most of the errors in basic annotation, but there are a few more errors also in prediction. When we go to coordination, the quantitative figures, number of predicted dependencies, is the inverse. And this is again because Stanford uses this high precision strategy where they only propagate dependence if they're core arguments, whereas the Finnish system goes for everything. So as a result, the Stanford system has slightly better precision, but not by a lot actually, and of course much lower recall. But we see that especially for the high recall system, we now get a fair number of prediction errors. The situation for Italian is again similar, but the precision scores are a little lower. And I will come back to that. Finally, when we come to ellipses, we only have predictions for the Stanford system because the Turku system doesn't handle this. And what we see is that for Swedish, it seems to work very well because, again, the majority of errors were in the basic annotation, and And in fact, there were only 2 incorrectly predicted dependencies. And considering that gapping is difficult, I think this is quite interesting. For Italian, it's a little bit different, and I'll come back to that again in the error analysis. So, starting first with the subject. I already said that a rather uninteresting difference between the system is that Stanford has higher recall for both languages because it handles not only infinitives, but everything that is treated as an ex-comp in the UD annotation. So here is an Italian example, meaning something like the Virunga part has become a dangerous area. In the UD annotation, the dangerous area is treated as an ex-comp of become, and then meaning that the thing that has become a dangerous area is, of course, the part. So this is an easy sort of dependency to predict. But the Finnish system doesn't handle that case. It would be easy to identify. Now, Stanford, as we saw, has higher precision for Swedish because it handles object control. So in Swedish, you can find examples like, if you let the money remain in the account, implicit, until the end of 1971. This is a very old brochure for how to do your tax return in Swedish from 1970. And in this case, just like in the English example, let the money remain. This is object control, so the thing that should remain is the money and not you. And the heuristic used by the Stanford system gets this right because there is an object. The poor Finnish system cannot find this controller. So all it can do is make a binary decision on whether this should be the controller or not. And in this particular case, it made the wrong decision. And there are enough of those cases so that this would get lower precision overall. Now, interestingly, for Italian, Stanford has lower precision, and it's for precisely the same reason, namely that it handles object control, which is kind of funny. So, and the reason is that in Italian, it's more common that the controller is neither the subject nor the object, but something that, at least according to the UD scheme, is annotated as an oblique. So this sentence means something like, and the Zagreb authorities have forbidden journalists to go to Petrinja. But the journalist here is not a direct object. It's some kind of oblique or possibly dated object or here. So there is a preposition. So what happens here, of course, is that the Stanford system doesn't find a direct object and therefore happily predicts subject control, which is wrong in this case. The Finnish system also doesn't find an object, but can at least sort of abstain from predicting this to be the controller. So therefore, okay, moving on to coordination. We already saw from the raw numbers that Stanford here has higher precision for both languages because it doesn't even try to solve the alpine skiing versus swimming example. It limits itself to core arguments. But of course, Turku gets higher recall because it goes after some of those. But by far the most common error type, especially for the Turku system, although there are cases even for the Stanford system, is predicting that a left dependent of the first conjunct, like this, is actually a shared dependent when it isn't. So this is more Swedish tax legislation. For natural persons, estates, and family foundations, the right to make deduction is cancelled. Now, natural persons in Swedish are called physical persons. So physical is a modifier of persons here, but it shouldn't be a modifier of estate or family. It's not. We're not talking about natural estates. We're just talking about natural persons, estates, and so on. But the Turku system predicts an added dependency here. Here is another one from Italian that I think you should be able to filter out because it's a case where it says everyone knows where they come from, but no one does anything. So note that in this case, the second conjunct here, the does, actually has an overt subject itself. And then, of course, we know that it's not, this one is not shared. but the simple data-driven system doesn't have sort of a filter like that. So this is an obvious thing that they could probably improve, at least for the core arguments. In other cases, it might be more tricky, but for the core arguments, you could definitely filter out these cases. When it comes to ellipses, it turns out that the Stanford system developed for English works surprisingly well for Swedish. In fact, they did a parallel evaluation for English, and it turns out it works better for Swedish than for English. Probably has something to do with the type of texts that are in the respective treatments. But on Italian, it gets lower precision. It's interesting to see that, at least partly, it has to do with different word order constraints. So you may remember I mentioned that this new method for ellipses used word embeddings and similarity matching, but also assumed that things would be in the same order in the two clauses. It turns out that in Italian, and maybe also in English, but it turns out that this Italian is more liberal in this respect. So here is an example where we have something like, in the district of Barra, 150 persons have been arrested, 70 others in the region of Bologna. So, whereas in the first clause we have the locative modifier before the verb and the subject after the verb, then they switch order in the gapped clause. And because of this constraint that is built into the algorithm, the Stanford system will predict that the 70 others is an oblique, whereas in the region of Bologna is a subject. And it's easy to see that if you relax this constraint so that you, when you did the matching on similarity, you tried all possible combinations. I'm sure that distretto, district, and regione, region should have very similar word embeddings. And maybe also, less obviously for Persone and Alte, but it's not inconceivable that it could handle cases like this. All right, so conclusion. We think these results are encouraging for bootstrapping UD tree banks, considering the fact that at least for in the case of Finnish, we have a completely unrelated language to our target languages, English and Swedish. But it still seems that for many of the enhancements, you can get high precision, high enough to use as a sort of first step, and then do, of course, manual checking and validation. But it should be at least quicker than doing everything from scratch. And also, the error analysis suggests some obvious improvements, and a few language-specific adaptations should probably help a lot. And as a sort of byproduct of this, I'm very happy to report that in UD version 2.2, which is due in a week or so, Swedish will now be one of the languages that have enhanced dependencies. Now, in this study, we focused on the case of enhancing tree banks. But of course, another possible use of these enhancers is for parsing purposes. So that once you have trained your ordinary dependency parser that predicts basic dependencies for a given language, you can apply enhancers like these to post-process the basic dependencies so that you can get enhanced dependencies. Now, obviously, you will get more errors in doing this because the tree bank case is a particularly good case where we have almost gold standard. You saw that there were annotation errors, but in the case of parsing, we will of course have parsing errors. But for many practical applications, it might be good enough, or at least better than nothing. So, thank you very much.
Okay, so thank you for a very interesting insight into building the enhanced corpora, and we have time for questions.
Thanks for a nice presentation. In the last slide about the Turku system, there was a point that it detects what labels should be assigned to the shared dependence. Is there a case where a shared dependent has different labels to its different parents? And still, even if the probability is low, is there a constraint that it should be higher chance that the labels are the same?
I don't need to find this out.
Probably not.
Yeah, no, that's a very good question. There definitely are cases where the label should be different. Because in coordination you can have, because the UD taxonomy is sensitive to whether the head is a noun phrase or a clause or something like that. And in some cases, it's not common, but you can have cases where a noun phrase is coordinated with a clause, and then you have something that is attached as a modifier to the noun phrase, and it gets the unique label. Oh, sorry, that's not. It gets the M-mod label because it's modifying the noun. But then if it also modifies the clause, then it should have the unique label. There may be more plausible examples than that, but then we definitely saw cases in the error analysis where the label should change. Something is a shared dependent, but according to the UD taxonomy, the label should be different. I think in principle, I'm quite sure the standard system cannot handle that, at least not in the current version, because they just copy the labels. I think the Turco system could in principle handle that, because they're actually predicting the label using features where some of the features are properties of the other head. So if you could see that the head is actually a verb now, not a noun, then it could predict the label. I cannot remember seeing any real cases in the analysis where it did make that right prediction, whereas the standard did. But maybe if I go back and look further.
Yes. I think we had some examples of this in the Prague dependency tree bank, but we couldn't annotate it in the original PDT style. There was just one label for the shared dependence. But okay.
Any other questions?
With the ellipsis, when the predicate node is elided and we add one, and this might actually, I'm sorry, but this might require going back to the example slide.
Tell me when to stop.
It's
maybe the early ones where I have.
yes. This one, yes. So I really like the elegance of the solution where you add the enhanced edges for the predicate, subject, predicate, object relations where you cannot get them from the basic ones. So why are we adding the ellipsis node here instead of just linking this 3 to apples and he to bought?
You mean having a link from 3 to apples?
Yeah.
And he to bought? No, he to she then, for sure.
No, he bought and she bought.
Okay, so but then 3 should also be linked to bought, shouldn't it?
No, well, right, because you cannot disambiguate then who did 2 and who had 3, right?
I think there are 2 different things you can do there. And one is actually what UD did in version 1. And that was known as the remnant analysis.
Mm.
So the idea would be that you would actually link the thing over here to its corresponding thing over here.
Mm-hmm.
So you would actually have a link called remnant from he to she, and you would have another one from 3 to apples. So that these links would say something like, I play the same role in the second clause as the thing I'm linked to in the first clause. Now, as I said, that was the official guidelines in the first version, but people were in general unhappy about it, and for a couple of reasons. One is that it tends to create very non-projective structures, so you easily get lots of crossing links that way. And you may or may not think that's a problem, but it's a fact. The other thing is that there are cases where the thing over here, there might be a modifier over here that doesn't correspond to anything over here. The standard example we have in the guidelines were something like, many people left the company, some for good. Where for good doesn't have a corresponding sort of modifier in the first. And then what you do, then you have nothing to link it to. So the other thing was that people felt that it should be clear from the annotation that you have two clauses being coordinated here. So you should have a connected substructure for one clause here and a connected substructure for another clause here, and then a link between them, rather than having these links that sort of cross the boundary. So I think those were like the main arguments for this. But then I guess there is another alternative that you say, and that is to, instead of inserting a new verb node here, just use the one that is over here, right? So then you could say that he is the subject of bought, and 3 is the object of bought. Now, that solves the problem with, that avoids the problem of things that don't correspond to anything in the first place. So the sum for good would be okay there. It still has the problem that it creates links that sort of cross the clause boundary. So again, you might have a preference. And I think some people would also argue that there might be cases, but this is probably getting too sophisticated for UD, where you have scopal elements that where you get the wrong interpretation because there might be a quantifier or something here, and it only scopes over one clause. But if you now treat it as an argument of the first predicate, I'm not sure, but yeah.
There is also a third argument that, especially if you have 3 things coordinated, then it would be very hard to distinguish the second and third, who actually bought 3 and who bought 4, or whatever the next one is. Yeah.
All right, thanks.
We have maybe
Well, I have a basic question. How do you identify the second part of the sentence as a clause, simply, if a verb is missing? Because there is a he, and it must be a subject of something. If a verb is missing, then the whole structure is really difficult to parse.
It is. I think the I think in cases like gapping and these and cases like that, I think I think it's based on, first of all, you can of course have even more reduced clauses where you only have sort of one element left. Let's say only the subject or only the object. And there I think there might be cases where you could actually debate whether you should still treat this as a clause or whether it's better to just treat it as a noun phrase or a prepositional phrase. I think in the cases, especially the one where you have a subject and an object, I think it's, I guess maybe it's mostly intuition in this case, but there is a very strong feeling that there are 2 parallel clauses, and there's a fairly large literature on gapping that studies exactly what that, saying that some features over here get copied over here, but others don't. So for example, tense should be copied, but agreement features should not be copied, because you could have a singular argument subject over here and a plural. But I guess in this particular case, I think we're mostly just relying on the traditional analysis.
I see. Thank you.
So I don't know if this is super necessary because the enhancers look to be working really well. But did you also try any experiments on just straight up parsing and trying to parse for enhanced dependencies without necessarily having the basic ones already in the parses, or sort of jointly?
In connection with this study, we didn't. And I think the reason was, the thing is, like I said, the tree bank enhancement or the tree bank bootstrapping scenario is kind of special in that you have, or you think you have, gold basic trees. And you know that they are always going to be better than anything that any parser can produce, regardless of whether that parser parses to trees or to general graphs. So it would kind of be stupid not to use that. In the more general case, when you're thinking about producing enhanced dependencies, sort of for new data, absolutely. No, I would say it's very much an open question. What is best? Whether you should try to parse directly to a graph structure, which of course makes the parsing problem computationally harder, but could have other benefits because you're jointly inferring all of these dependencies, as opposed to first producing a tree and then in some kind of post-processing step. I mean, I think there is sort of an emerging literature on graph parsing. I mean, graph parsing can do different things, but this type of, there has been the shared task on semantic dependency parsing using, for example, representations derived from the Prague dependency tree, but also from other resources. There, I think that the best results so far have been achieved by systems that use a fairly conventional syntactic parser that produces trees first and then post-process them. But I think it would be a mistake to conclude from those results that that's always going to be the case, because obviously tree parsing has been studied a lot more than that. So I think it's perfectly possible that once we figure out how to build better graph parsers, that would work.
Cool. Thanks.
Please, any other questions?
Well, if we stick to this slide, have you considered other ellipses and whether to only work with this one type of ellipsis of subject, of a predicate, or why not do the three also? Would be my question.
Well, I don't know. Maybe in UD version 3, that's what we'll do. I think a lot of people were very reluctant to introduce empty nodes at all in the tree bank annotation because it does make some things more complex and also for parsing. So I think it was a relatively big change to, even though it's only in the enhanced dependencies, not in the basic dependencies. And I think it was, many people felt that we should be really, really restrictive and only introduce them when we really can't think of anything better. And as you know, not having the predicate or not having the verb is probably the worst case that you can have in a dependency representation. But in principle, once we've started going down this road, I guess I don't have a principled argument.
Yeah, that was mainly my question: whether there is a principled argument why other ellipses cannot be there, or whether it's just.
I don't think so. I think it's possibly it could be the case that I don't know. The kind of thing where you drop the head noun and you just use a numeral or an adjective or a demonstrative or something like that. That seems to be a very general phenomenon that applies in many situations, and it probably doesn't require specific grammatical structural contexts or something like that. But I'm not sure it's really a principled argument, but it would mean that it would probably create a lot of cases where it would be hard for annotators to know whether there is ellipsis at all, or whether it's the adjective, it's a nominalized adjective, and whether that is lexicalized or not. So there would be a lot of these, whereas at least the gapping case is rather distinctive, right? I think we're maybe not sure about the criteria where I am, but most people would agree that yes, there is a verb missing there. But again, it's definitely a scale. It's not a sort of distinct categories.
Anyone else? Okay, so do we know which other tree banks will have enhanced dependencies in 2.2?
I don't. If anyone knows, it's probably done.
10 languages, 15 tree banks. As of now, it's actually not the complete release 2.2 because it's only the tree banks that are large enough to appear in the shared task that we are organizing. So there might be others, although I don't think so.
Any other questions?
So this is more of an open-ended query. So we've seen the graph structure get a bit more complicated, but we still see that it's a priority to kind of keep it as simple as possible, not to introduce too many non-projectivities, etc. But if you look at this process of complicating it even a little, do you see this as something which will go ahead, which will get more complicated in, I don't know, UD more enhanced in version 3 or something, as also the graph parsers evolve? Do you see this as a good way, and maybe a new way of capturing this kind of tricky linguistic structures to keep in a tree?
So at a fairly early stage of the development of UD, I think this was at the Darkstuhl seminar where Jakob also that eventually we'll probably end up reinventing the tetragrammatical representation of UD. We're not quite there yet, but who knows. It is a trade-off, and that's, I mean, in many ways UD is an almost impossible balancing act, right? Because you want to sort of, on the one hand, balance sort of practical NLP concerns versus more theoretical linguistic considerations. You want to balance ease of annotation, which versus capturing many phenomena. You want to balance being able to actually parse the structures with high accuracy, but then, as you said, if graph parsing gets better and better, maybe that's not a major consideration. So it's really hard to predict what will happen, especially in a sort of open community like UD. I don't think we have seen the last enhancements, and there are certainly already proposals from different groups for more things to add. I think it is probably wise to proceed at a relatively slow pace. Also, as the number of tree banks increase, we know that for every change we introduce to the guidelines, we're imposing a lot of effort on people who are maintaining the tree banks. And that in itself means that we owe it to ourselves and to our colleagues to be really convinced that something is really an improvement and something that is necessary before we add it to the guidelines. But, yeah.
All right, thanks.
Okay, so you can still raise your hand, but if there are no more questions, I just wanted to remind you that actually Joachim is here until Thursday. We have already set up meetings with people because the main purpose, in fact, is that Joachim helps us with developing the new structure and the new courses in our master's and PhD programs. I mean, officially the PhD program. So there are already meetings set, but I think there are still some free slots. And so if anyone is interested, please write to Ondřej, who is actually now responsible. Ondřej is not here. Ondřej Bojar has a schedule and knows what are the free slots and so on. So please write to him, and then we can set up more. So once again, thank you very much. You will be always welcome here, even with enhanced plus and version 3, and we are of course happy to finish with complete tetragrammatical annotation in UD. And thank you once more again.